Okay, so you want to dive into some seriously complex stuff, huh? Well, get ready, because today we're taking a look at this code that's trying to connect, get this, the Riemann hypothesis, fractals, and data storage.
Yeah, it's a pretty wild combo, gotta admit. Let's see if it's brilliant or just someone's wishful thinking, you know?
Right, totally. First things first, though, we got to talk about the Riemann hypothesis.
Yeah.
Everyone's heard of it, but like actually explaining it, it's a whole other story.
It's one of those math mysteries that's kind of hard to wrap your head around.
Yeah, for sure. So imagine like trying to guess where a skipping rope's going to land while it's spinning. That's kind of like prime numbers. Those numbers you can only divide by one in themselves. They just pop up kind of randomly.
And the Riemann hypothesis wants to find like a pattern in that randomness. It's all about this thing called the Riemann zeta function. Don't worry about the details. But basically, this function has these special points, zeros, and the hypothesis. It's all about predicting where those zeros should be.
So it's kind of like where the skipping rope hits the ground, those zeros,
Yeah.
except with like an infinite number of skips.
Exactly. And here's why those zeros are a big deal. If we knew where they all were, it could change how we understand, like, all numbers, not just primes. It'd be huge, mathematically speaking.
Whoa, okay. Huge implications. Now, throw fractals into the mix. You know those trippy pictures online where you zoom in and it's the same pattern forever?
Right, right. Like, think about a coastline. Up close, it's all jagged, but even from far away, it's still jagged, just on a bigger scale. That's a fractal.
And this code wants to connect that to the Riemann hypothesis. Okay, hold up. Prime numbers, infinite patterns, and now you're telling me this is also about data storage. Did someone put something in my coffee?
Well, this is where things get really interesting.
Ah.
See, this Python code, it's not your usual solve the problem kind of code. It's more like a playground for ideas, you know. We got functions here called AdvancedRiemannAI.
Like an AI trying to do math? That's kind of scary, actually.
Idea. But cool, what it's doing is trying to find those zeros from the Riemann zeta function, but then there's this other function, Riemann fractal, and this is where it gets wild.
Let me guess. It makes fractals.
You got it. But it's using the Riemann hypothesis to do it. Like, it's trying to build a 3D fractal using math that's all about prime numbers.
Okay, I'm kind of lost, but also kind of amazed. But how does data storage even fit into all of this?
That's the million-dollar question. We see encode data and decode data functions, which is a huge hint. Like, someone's trying to figure out how to put information inside the fractal itself.
Wait, hold on. Storing data in a fractal. How is that even possible?
Think of it like, imagine a treasure map, right? But instead of an X, there's this crazy complex fractal. Each point on that fractal could be a piece of information.
So instead of my files being in, like, documents and downloads, they'd be, what, on some digital fractal island?
Something like that. Yeah, it'd be like a whole new way of thinking about where you put your files, that's for sure. But instead of folders, it's all about finding the right spot on this infinite twisty structure, you know?
My brain's already starting to hurt just picturing that. But okay, let's say we could actually do it. Like, we got computers powerful enough to put data into a fractal. How would we even get to it when we need it? We're talking like quantum computer stuff here.
We're definitely talking tech that's way beyond what we got now, that's for sure. I mean, you'd need crazy processing power, but also like whole new ways of even thinking about how to find data.
So like, forget upgrading my laptop. I need a whole new kind of computer, right? Got it.
Yeah.
But humoring this for a sec, why even bother? If we can barely wrap our heads around it, what's the big advantage to fractal data storage?
The potential. Oh man, it's huge. Think about it. You could store like an insane amount of data in a tiny space. We're talking like the entire Library of Congress, but on something the size of, I don't know, a flash drive.
No more deleting photos to make room for more photos. Sign me up.
Exactly. And it's not just about the space. Imagine the possibilities, like in medicine, they could store massive amounts of research data, or in space exploration, where telescopes are pulling in tons of information every night. This kind of tech could change everything.
Okay, I'm starting to see the appeal here. But as cool as a pocket-sized Library of Congress sounds, there's got to be a downside, right? Besides the whole, we need to invent a new kind of physics thing.
Well, yeah, the tech to actually build this kind of thing is, let's just say, a long way off. And it's not just about computing power. You'd need breakthroughs in materials and how we build things at, like, the tiniest level. Plus, imagine the energy it would take to make these crazy fractal structures. Probably not very eco-friendly.
So not something to put on your eco-friendly wish list just yet.
Not yet, no. But that's what's so cool about these kind of ideas, right? It forces us to think bigger, beyond what we think is even possible, pushes us to explore and try new things in science and tech.
Like we're standing at the edge of, like, completely uncharted territory. Got a compass, but no map.
Exactly. And that's why this whole thing is so fascinating. This code, even if it's just theoretical, it's showing us a potential future where math, computers, and even like philosophy all kind of blend together. It makes you wonder, are we even close to understanding what data storage could be?
We started with some weird Python code, and now we're here talking about prime numbers, infinite patterns, and like the meaning of information itself.
It's a lot to take in, for sure. But that's what a good deep dive should do, right? Push those boundaries. And if there's one thing we've learned, it's that sometimes just asking the question is more important than actually having the answer.
You know what's mind-blowing as all this is? I gotta say, a part of me still thinks, is this for real? Like,
Yeah.
are prime numbers, fractals, and data storage actually connected? It seems almost too crazy to be true.
Yeah, it's like finding a hidden code that links like ancient hieroglyphs to the internet or something.
Exactly. But that's the thing, this code we're looking at, it's suggesting that this connection really exists. It's like the
Yeah.
universe is way more connected than we ever realized.
Right, like we think we're so advanced, but maybe we're just getting started. Maybe we're still using stone tools when there's blueprints for like spaceships just waiting to be discovered.
That's a good way to put it. We might look back at our hard drives and be like, seriously, that's how we used to store stuff.
Totally. But for now, we just got to keep asking the big questions.
That's what this whole deep dive thing is all about, right?
Yeah,
Not always finding the answers, but knowing what to ask. And this one's a doozy.
for sure. We're talking about pushing the boundaries of what we thought was possible, like blending math, computers, even philosophy, to understand data in a whole new way.
And hey, who knows what other crazy connections are out there waiting to be found, right?
Exactly. That's the beauty of it all, isn't it?
So, to wrap things up, we went from some mysterious Python code to, like, the future of data storage and the universe itself. Not bad for a day's work, huh?
Not bad at all. And if there's one thing to take away from all of this, it's that sometimes the journey is just as important as the destination.
Couldn't have said it better myself. But hey, here's one last thing for everyone to ponder. If we actually figure out this whole fractal data storage thing, if we can suddenly store, like, infinite information, what are we going to do with it? What are the possibilities? And, what about the risks? That's something to think about.